USACO, the December competition is starting on December 18th, which is Friday. So that's in like 2 weeks, a bit over 2 weeks. And it'll be from December 18th to December 20th. So if you guys are like planning to compete or just try it out, would recommend you like at least take a look and just kind of like feel around, see the problems. Maybe like you're really good at it for some reason. But anyways, we're gonna be talking about brute forcing. But first, we're gonna go over a bit of a review over some of the problems from the last lesson. Then we'll explain what is brute forcing and like what is time complexity. And then we'll go over an example and kind of like have a teensy bit of practice. So first from lesson 7, which was the last time we met, that was arrays lesson, and there are a couple missing number problems that we went over. So the code is on GitHub. So you guys can go to our GitHub and find all of this code. But just very briefly, so the problem statement, which is on the left, right? So it asked, given like an array of numbers, and then there's one number missing, and you have to output that missing number. So there's like a couple methods to do this. The first method is like doing it like this. Basically, we store n, or 5 in this case, right, which is the highest number, and then we create a new empty array and then store each of these 4 values into that array. And then we sort the array using arrays.sort. So it goes from least to greatest or smallest to greatest. So it gets sorted to 1, 2, 4, 5, because this one's actually already sorted. Like for this problem, for example, it was sorted to 1, 2, 3, 4, 6, 7. And then basically we loop through all of those elements and check if like a number is missing, right? So when we loop through, we'll check 1 is there, 2 is there, and then we'll check 3 is not there, and then so 3 is the missing number. And so this is a pretty fast solution. Though there are better solutions. I think one example of better solution um, over here. So as you can see, the code's a bit shorter, but the main difference is we did a bit of like math, right? We used the formula here. So this formula is the formula for the sum of a sequence. Like we learned this from algebra. So n times n plus 1 divided by 2. So if we apply that to like our sample input here, 5 times 5 plus 1, which is 6. So 5 times 6 divided by 2 is 30 divided by 2, which is 15. And so that's the sum of 1 plus 2 plus 3 plus 4 plus 5. And the reason we're doing that is because we know the sum of 1 to 5 is equal to 15. And then when we subtract each of these given inputs, we're going to be left with the missing number. So for example, the sum is equal to 15. Then we subtract the next integer, which is 1. So we're left with 14. Then subtract 2, so we get 12. Then 4 is 8. Then 5, so we get 3. And that's the answer. So like this shows like how, right, with a bit of math, you can like clean up your code, make it a bit faster versus like this solution, which was more of a like try everything, which was more of a brute force solution. And then the next problem, which was multiple missing numbers, it's like the exact same concept, except for example, right, this time we're given 1, 3, 5, for example, and there are multiple missing numbers, which are 2 and 4. And because like we don't exactly tell you how many numbers are missing, we're just kind of like telling you that we're giving you a certain amount of numbers and you have to output every number that's missing from this list. So this is a good example where we're going to use an array list. If you guys remember, an array list is basically the same thing, except it like has it doesn't have a fixed length. So you can add as many integers and remove integers, blah, blah, blah. And so to add these integers into our array list, which is called input, by the way. So we're going to use this like function or this method or whatever you want to call it, basically in.hasNextInt. So in references the scanner, which grabs the input, and then hasNextInt returns true if there's another integer waiting in the input, and returns false when there is not another integer waiting in the input. So basically you'll add every integer left inside the sample input into the array list. And then all we need to do is loop through and check if each number from 1 to 5 exists in the array list. So the way we did it here was we used this index of, and index of returns the index of the element, or it returns -1 if it doesn't exist. So input.index of 1 to 5, right, each option. And if it returns -1, that means it's missing. And there's actually a better way to do this, but we didn't cover it, but I'll just show it really quickly. So instead of like having this index of and it equals -1, we can do this contains, and then we can do the same thing. So contains is very similar, except it returns true if the number is inside the array list, and it returns false if it isn't. And it's actually, it like serves the same purpose. It's just a bit less code and a bit neater, and it'll still work the same way. And so that's like our review of those answers, the problem statements from last time. And just remember, everything's on GitHub. So if you didn't get it, you can read the comments and you can view the same stuff there. And now we're going to talk about what exactly is brute forcing. So most of you guys probably have heard this before. It's like trying every option extensively. And so brute force or complete search. So in many USACO problems, it suffices to check all possible cases in the solution space, whether it be all elements, pairs of elements, subsets, or permutations. And that's called brute force. And you're almost guaranteed to see at least one brute force problem in bronze. You're probably going to see around two, but probably not three, but you're almost guaranteed to see at least one of these. And what's so unique about brute force problems are, so for example, if you like had a password about like a 6-digit combination code, brute forcing would just be trying every single possibility, starting with like 0000001 and then going to 0002 and just keep going up. And the pros is that it's very easy and uncomplicated, right? Like all we need to do is create a for loop and just increment this number by 1 each time. And you're guaranteed a solution because you're checking every single possible solution. But some of its cons are that it's very inefficient and it takes a lot of time. And you can't do this for every problem because like in competitions like the USACO, there are like time limits on your code. So I don't remember the time specifically, but like it's designed so like you can't like just like your code has to run within a certain amount of time, otherwise it will time out and you get an error. If you ever receive a timeout, that means that either your code like takes too long to run, or you have some sort of error where like it's a while loop that just doesn't stop looping or something, for example. But basically, brute forcing, if a problem is brute forceable, you should do that because it saves you time and it guarantees a solution. And so one example of a brute force problem that some of you guys might have seen before is HackRank. This is two-sum. This was from lesson number 4. So basically, you were given an array of integers and then a target, right? In this case, the array of integers is 2, 7, 11, 15, and your target is 9. And you want to come up with two numbers that make up target, right? So in this case, 2 and 7, 2 plus 7 is equal to 9. So you output the index of 2 and 7, which is 0 and 1. And the same thing for this one, 3, 2, 4. To find two of them that make up 6. So we choose 2 and 4 because they make up 6, and we output 1 and 2. And so this is a brute force problem. You would just simply check every single possible case. And actually, this is LeetCode. It's another website. It's very similar to HackerRank, except this one like has some very nice expert solutions. So I'm just kind of borrow this. As it shows, this is the same exact problem, just maybe some different formatting. But approach 1 was brute force, and it's just very simple. You loop through each element and find if there's another value that's equal to your target subtracted by that element. And so you can see in this code here, they basically just have a for loop to run through each element, and they have another for loop to check if it's equal to whatever the target is, basically. And so it even shows the complexity analysis, which Josh will get into a bit later. And actually so does O of n squared, but we'll talk about that later. And so as you can see, it's very simple. The code is very short and you'll probably get it like first try or second try. However, there are better methods that are faster. For example, like it gives you some like hash tables, some more hash tables, but those are much more complicated. You need to know what you're doing with them also. And basically it's the same answer, but brute forcing is just a bit easier, especially if like, for example, you don't know what a hash table is. And so I think that's, I think now I'm gonna pass off to Josh and he's gonna continue talking.
So, Time complexity. So time complexity is a term generally described to describe about how long something is expected to run for, and how much longer it'll take given a bigger set of values. So right here, the amount of computer time it takes to run an algorithm, and you will see when people talk about time complexity, they'll give you sort of like values like this, where it has like an O and then something, some kind of equation or expression inside the parentheses. And the important part is the thing that's inside the parentheses, so like this number one, this log n, that describes generally how long it'll take to run whatever method the time complexity is describing. So it's a bit kind of hard to explain it, but basically, if the expression inside is bigger, then generally the program will take longer to run, and the time it'll take to run will increase exponentially as you add in more values. So on the right, we have a graph. So these are just graphs of just an equation. So you can see n is linear. You could reference it to like the equation y equals x. That's just n. So that is called constant time. So going through them, here are some examples of different sort of time complexity to give you an idea of what each one would mean. So O1, that one would be, this is like the optimal thing where no matter how big of a data set, it always takes the exact same amount of time. And one example of that would be the median and sorted array. That's just the middle number. No matter how big your array is, it's going to take relatively the same amount of time to find the middle number in a sorted array, right? You just get index of the entire length divided by 2, that's the middle array. So no matter how big it is, it's going to take very quickly and pretty much the same amount of time. Next up is binary search. So binary search, obviously it takes longer to run than finding the median in a sorted array, and that's why given the equation log n. So as you can see down here, log n down here, it's sort of like this sort of curve out. So if you remember what binary search is, it basically cuts the array in half when it's searching for a term. So bigger terms, let's say you have a term of 50 and a term of 51, the difference is very negligible since when you divide by 2, they both equal, they both get like a subdivision of 25. So the bigger number it is, it's about to take the same amount of time. Let's get that a bit complicated. But next up is ON. This is linear time. So as you can see, it's just a straight line. As the number of values you have increases, the amount of time it takes also increases. So it's like a linear search. If you have 5 numbers and you search them one by one, if you have 10 numbers, it'll take about twice the amount of time to search through them because you have twice the numbers and so forth. And then brute forcing generally would take the longest amount of times and will be in the bottom. So n factorial, you can tell, is a very big number. And that's where brute forcing is, or generally is, where you have to test every single possible combination. So if you know the time complexity, you can try to use that to optimize your code and things like that. So here, if you want to do some practice of recognizing time complexity, we have 2 examples here. First one, there's 2 for loops inside each other, and that's the for loop. The second one is 2 separate for loops. So I'll give you about 10 seconds. You can try to figure out what time complexity it is. And remember, it's something like that, just an equation. Okay, so it's okay if you don't get it, but you can obviously, first of all, you should be able to tell that the left one will take longer to run than the right one. Since this one, you have to run through the inside, or you have to run through it basically in a squared fashion. So you run the inside one n times, and then run that entire thing n times, so that's like n squared. So the time complexity for that would be n squared. The right one is much faster. You just run through them once, 1 to n each for each of them. So that's about 2n since you run through n different cases 2 times. So that's 2n. And you can simplify that down to n since it's relative. It's pretty much the same. So by looking at time complexity, you could tell the right one is going to be much faster than the one on the left. So that's complexity. So practice problem for brute forcing. Eric is going to send a link in the chat about that takes you to this problem statement. And if you're too lazy to read it, I'll explain it right now. So we have farmer John. This is an example of how to of a more advanced form of brute forcing that still uses pretty simple programming So we have Farmer John. He has 3 buckets, X, Y, and bucket M. So bucket M is the biggest bucket there, and he wants to figure out using bucket X and Y and pouring milk from bucket X and Y into M, what's the most amount he can fill bucket M up to without overflowing it. So he just keeps putting bucket X and Y until bucket M is almost full but not overflowing. So first of all, you have to think, how will you attack the problem? So brute forcing is one of, you can think of that, but brute forcing, you can't just say brute forcing and be done. You have to figure out how to brute force. Since if you just randomly select X and Y values, you might get the same values again and again. It's not guaranteed you'll get the solution. So there has to be a systematic way that you can test every single solution. So the system you could come up with would be to first fill M up to its maximum capacity using bucket Y and record a maximum value. Then start taking out buckets of Y and putting in buckets of X instead, and try to see if you get any closer to the maximum capacity of bucket M. I'm not sure if that makes sense. If it doesn't make sense, text me in chat and I'll explain it a bit better. Without further ado, let's start doing a quick programming of it. So our task is to first fill up bucket M using bucket Y's. So this entire front part you can ignore for now. That's just how USACO will give you the values. And the ending part here will be how USACO expects you to output the answer. And if you want to learn more about that, you can talk to us and maybe join in the USACO centered class to learn more about how to prepare for USACO. Anyways, back here, so to get the oh shoot, hang on. Yeah, so this is Eclipse. This is IDE for programming. So we can start. This front part is to get values from USACO, and this bottom part is outputting values to USACO. And join the USACO class to learn more about it. So let's get started. First of all, remember our how we're going to attack the problem is we're first going to try to fill a bucket M using only bucket Y. So for that, we just very simply have a variable total that we set up. These three variables will come to use later. So total will keep track of how much milk is in bucket M. And while you can add another bucket Y without overflowing it, then you add bucket Y to it. So as long as you can still put another bucket Y without overflowing, we add another bucket Y. And we also keep track of how many bucket Ys we use by increasing count. And now, once it gets to the point where you can't add another bucket Y without overflowing, we can set that as our current maximum. So maximum will be representing the maximum level of milk we can put inside bucket M without overflowing. So right now, it will be set to total. And now time for the brute forcing part. So we're going to take out 1 unit of bucket Y out of bucket M, and we're going to try to fill in the empty space with bucket X until you can't do it anymore, and then repeat that until we replace all the bucket Ys with bucket X's. And that should give us somewhere along the lines, there should be a maximum value that appears. So while count is greater than or equal to 0, which means while there is still bucket Ys existing inside bucket M to take out, we will use total. We will add a bucket X. Wait, no, shoot. So while you can still take out bucket Ys, and also while you can add a bucket X that doesn't exceed the maximum, then we're going to add a bucket X. And we set maximum to whichever number is bigger, whether the current number is bigger or the previous maximum is bigger. So it's whichever value of the two is bigger, we're going to state that as maximum. And after you can't fill a bucket X anymore, then we will take out the bucket Y and subtract count. Now what this does is as long as you can still take out bucket Y, or take out bucket Y, fill it with X, check the maximum, and then repeat again and again. And once you cannot take out any more bucket Ys, count will be 0, so or count will be -1, so that will exit the for loop. And theoretically, what you have now should be what's stored in maximum should be the maximum amount of milk you can put inside the bucket. And you print that out using the max, calling the max variable. And if you run it using the test cases, which I have already set up, you will see that it works. So test case in, test case out, 76 is correct, and so the code works. So brute forcing, test every combination, and this is sort of a more strategical way of brute forcing where you have a plan in mind to actually do it. So I'll hand it back to Eric now.
All right, so first, if that was a bit like confusing for you, that's also fine. We'll post the code later on GitHub and stuff. And that was also a USACO Brown's problem from like a while ago. Um, right now, I'm gonna start sharing again. So we actually have a hankering problem that we created. So it's like a much easier version of the it's a much easier like brute force problem that you guys might be able to do. But basically, I'm gonna send this in the chat. I'm gonna just quickly like read the problem. So basically, you're given n integer points on the coordinate plane. So that's like x and y, and then you need to find the square of the maximum distance, aka length of the straight line, between any two of the points. So square of the maximum distance, basically, if you guys remember distance formula, uh, so distance formula, right, is square root of x2 minus x1 squared plus y2 minus y1 squared. But it's asking for the square of the distance. So basically, just take out the square root. So all you need to compute is simply x2 minus x1 squared plus y2 minus y1 squared. And then that's just like for just like easier like workability, because the point of the problem is more of like the brute force concept. And so the input format, first line contains the integer n, then there's two more lines. The next line contains n integers, which are the x coordinates, then the last line is the y coordinates. And here are some constraints. Basically, you're supposed to print one integer, which is the square of the maximum distance between any two of the points. So for example, sample input number 0, so n is 3, so we got 3 sets of points. The first point is 1, 1, then there's 5, 1, and lastly there's 7, 1. And so this like is a very simple one, right? So like we can immediately tell that because like all the y coordinates are the same, like the farthest 2 points are going to be 1, 1 and 7, 1. And then so the distance between 1, 1 and 7, 1 is 7 minus 1 is 6, and we square 6, so that's 36. And then we know 1 minus 1 is 0, right? So basically the answer is 36. And it explains here. So if you guys kind of know what you're doing, or you like think you know what you're gonna do, you guys can like get ready and just try it out right here. If not, I'll just start off and give like some helper stuff, like some pseudocode a bit for like what needs to be done, and then give some time, and I'll like kind of show an answer before time's up. Um, so basically, once again, the first thing you need to do, right, is to, if you're unsure of what you're doing, you need to grab all of the input. That's like step number 1. So as you can see, we already created a scanner class or a scanner object for you. And then we already grabbed integer n for you guys already. So all you guys need to do is grab, grab the rest of the input. So the 2 arrays. And the easiest way to do that would probably just be to initialize 2 blank arrays. You could create a 2D array if you want to, and if you're familiar with them, but it doesn't really matter. So I'm just going to do int x is equal to new int, and then the size of the array is going to be of integer n, and I'm do the same thing for y. And then, so now I've created our 2 empty arrays. So now you guys want to kind of store the values into those arrays. And so I'll like quickly code that out, and then I'll stop like coding. So to store the values, you're gonna want 2 for loops. The first for loops will store all of the values into the x array. And the second for loop will do the same exact thing, except so we'll just copy and paste this, except it's going to do it for the y values into the y array. And so this code should work hopefully, and it will store you the values of the input. And then the next thing you want to do is you want to be able to somehow, right? Because we already told you this is a brute force problem. You should be able to like immediately recognize that you just want to brute force this, try every single possibility. So you want to somehow try every possibility and store the maximum. And then you want to and then you want to compare the max with the distance of each point. Uh, English is a bit off, but basically, all you need to do is check every single pair of points and then code in this distance formula right here and compare to see which one's the greatest. And also, if you're like unsure how to do squares, you can just simply do like x times x or like y times y or stuff like that. It will also work. So the meeting isn't done yet. Right now, we're just letting you guys kind of like take a stab and try this problem. And then in a couple minutes, I'm gonna like explain the solution and like code out the solution. I mean, if you have already finished this problem already, then you could probably leave because we're just gonna explain the problem later. But yeah. Also, if you guys like need help or are stuck, you guys can just let me know. I think I'll start explaining the solution in like 2 or 3 minutes, maybe. All right, so I'll just slowly start explaining the rest. So hopefully you guys like got somewhere at least, or like somewhere in your head at least. Um, but like so, next thing I'm gonna do, right? So now I've grabbed all the input. So we want to like store a like current maximum variable. So we're just gonna do int max is equal to 0, and then we're gonna continuously check if like the distance is greater than max, and if it is, then we're gonna set max equal to that distance. And at the very end of our like loops over here that we're about to write, we're just gonna print out max, which should contain the greatest length between any 2 points. So now we're gonna have to loop through, right? Like each pair of points. So to do that, we're definitely gonna have to use a nested for loop or like a for loop within a for loop. Um, but something to note or something like to kind of like improve the code a bit is that instead of like having your second for loop, just have for int j is equal to 0, j is less than n, j plus plus. We can actually make this a bit faster simply because, so for example, right, when we run the loop, we don't need to compare backwards. So basically what I mean is, so the first like numbers we're going to check is we're going to check 1 1 with 5 1, and then we're going to check 1 1 with 7 1, and then we reach the end, right? So now we're going to move 1 to the right. So now we're going to check 5 1, and then we don't need to check 5 1 with 1 1 because we've already done that earlier. Instead, all we need to do is check 5 1 with 7 1. And then when we move 1 to the right and we get to 7 1, we don't need to check anything because we've already checked it already, if that makes sense. Because we don't need to like go and check the pairs that have already been done. So to like code that out, we can just do for int j is equal to I plus 1. And so now no matter what, j is always going to be like, it'll always start 1 to the right of whatever I was. So you won't ever like start checking backwards for anything. So that's pretty useful too. And then now all we have to do is just code out like this portion right here. So x2 minus x1, right? That's right. Change of x dx is equal to x of I minus x of j. And it would do the same exact thing for y, except right, it just dy is equal to y of I minus y of j. And so now we have those two in the parentheses, and now we just need to square them. So int squared is equal to dx times dx. Then we're just going to plus dy times dy. And you can put them in parentheses, whatever. Or you could use the math.pal function, but this should work just as well. And then now we have the distance, right, of any 2 points and of each 2 points. And so now we just need to like do some comparing, right? So we could just write an if statement. So if squared is greater than max, then I'm going to set max is equal to squared. But there's actually a better way to do this. So we're going to comment this out. So a better way would be to do max, and we're just going to set this equal to, and then math.max of max and squared. So basically, I'm actually going to rename this variable. We'll just call this answer because like there's too many maxes going on. So this is going to be called answer now. It's the same concept. So basically math.max, what it does is it takes in like, right, it takes in 2 values and it returns whichever value is greater. So it's comparing answer and squared, and whichever one's greater, it's going to return, and an answer is going to be set to the greater value. So it does the exact same thing as this if statement right here, except it's a bit more concise and it's 1 line of code. And then so after this, we should be good, and we should just be able to print out our answer, which the variable is now called answer non-max. And so hopefully when we run this, it should work. Oh, I made this error. Yes. Okay. So my bad. We can't declare this to y because y is not a variable. This should be n instead. That was just a typo. All right. So that worked, and hopefully when we submit our code, it should also work. All right. Nice. So basically that was it. This is the code. We'll push this to GitHub a bit later. Our meeting's also over now. It's 1:09. So if you guys have any questions, you guys can stay. If you like need explanations of this code or something, that's also fine. But otherwise, you guys can leave, and we'll see you guys next week. Andrew, Devin, are you guys have a question?
I think we're just end the meeting.
Yeah, I'm gonna end the meeting.